Let's take a look at how we can calculate pH and some of the other variables that we use when dealing with acids and bases. There are 6 main formulas that we have available to us, and those can all be found on page 3 of your reference table. So looking at our first formula, here we are solving for pH using the concentration of H+. Remember, concentrations are always given to us in molarity. So if you see a molarity in your question, then that is going to be either the concentration of H+, or it could possibly be the concentration of OH-, which is hydroxide. And so we can use the concentration of OH- to solve for what's called POH. And that's very similar to what pH is. It's just measuring the amount of OH- in your solution instead of H+. The next formula relates both pH and POH. So we see that pH plus POH is going to equal 14. And then these two are just the reverse of the first two. So this time we are solving for the concentration of H+ using pH. And here we're solving for the hydroxide ion concentration, the concentration of OH-, using POH. And then our last formula here relates those two concentrations. So what we see is that the concentration of the hydroxide, the OH-, times the concentration of the hydrogen ion, the H+, is always going to be equal to 1 times 10 to the negative 14th. So let's take a look at some examples. So our first one says, what is the pH of a solution with a concentration of H+ equal to 1 times 10 to the negative third molar? Now there is a shortcut that we can use when our concentrations start with 1. And so that shortcut says that if your concentration is 1 times 10 to the negative something, then your pH is just equal to that exponent. And so this again is only true when your concentration starts with 1, like we have here. So the pH for this one is going to just be our exponent, which is 3. If you have any number other than 1 up here at the front, then you're going to have to use the formula that we learned about for pH instead of our little trick. But in this case, we were able to use that, so our pH is going to be 3. Let's take a look at another one. So this one says to find the pH of a 0.045 molar solution of HCl. Okay, so looking at what they gave us, so they gave us a molarity. Remember, molarity is always going to be equal to a concentration. And since HCl is an acid, this is going to be the concentration of H+. So our concentration of H+ is 0.045 molar. We are looking for the pH. Okay, so let's go to our formulas. This is a copy of what you would see in your reference table. And so we need to figure out how can we solve for pH using the concentration of H+. Well, if I look at this second formula right here, we see that it is solving for pH, because pH is on the left, using the concentration of H+. And so that's going to be our best formula to use. So we'll plug that in over here. Now plugging in our numbers, so our concentration of H+ was 0.045. And then plugging that into our calculator to solve, our pH is going to be about 1.35. Okay, let's take a look at the next one. So this one says to find the pH of a solution of sodium hydroxide that has a pOH of 2. So again, the first thing we want to figure out is what do we have and what are we looking for? So the first thing that we see is that we have a pOH of 2, and we are looking for the pH. Okay, so again, let's go to our formulas. Do we see one that has both pH and pOH in it? And we do. The very first one here has pH and pOH. So that's going to be our best one. So we'll say pH plus pOH equals 14. Now let's plug that pOH in. And solving 14 minus 2 gives me a pH of 12. Okay, our next example. What is the concentration of hydroxide ions? So we're looking for the concentration of OH- in a solution that has a pH of 10.47. Okay, so again, picking out what we know and what we're looking for. We know that we have a pH that's 10.47, and we're looking for the concentration of OH-. Okay, so let's look through our formulas. Do we have one that has both of those things in it? Well, if we look through our formulas, we don't see one that has both of those things in it. So that's going to tell us that we're going to need to use at least two formulas in order to get where we're going to go. Now for this one, the best thing to do is, since we are starting with pH and we need to get to the concentration of OH minus, the best thing to start with is going to be this first formula. With this first formula, we can plug in our pH and get a value for POH. Once we know our value for POH, then we can plug into this formula down here at the bottom, plugging in the POH right there and solving for the concentration of OH minus. So let's take a look at that. So again, the first formula we're going to use is pH plus POH equals 14. Plugging in our pH and subtracting. So now we have a POH of 3.53. Once we know our POH, then we can plug into the bottom formula, the concentration of OH minus equals 10 to the negative POH, plugging in and solving in our calculator. So that's going to give us a concentration of OH minus of 0.000295 molar. And remember, since it's a concentration, it's going to have a unit of molarity.